Okay, let's talk about dividing whole numbers. And we're going to do a couple things with this. The first thing is, again, we're going to do some basic division and we're also going to do some long division. But I also want to talk a couple things. And first of all, let's talk about a very important thing to know, and that is you cannot this divide by zero. Zero, this is one of the only hard and fast rules in mathematics. You cannot divide by zero. So if I have, one of the ways that you can check a division is by multiplication. So if I've got, say, 20, and I divide this by 2, 20 divided by 2, you're basically asking how many times do I have to add 2 to get 20? And it's 10. If I'm to check this, I'll be saying, well, what is 2 times 10? 2 times 10 is 20. Now you can divide 0 by a number. If I said 0 divided by 7 is 0, how many times do I have to add 7 to get 0? None. And I can check that by multiplying again. 7 times 0 is equal to 0, sure enough. Here's the thing. When I try to divide by 0, so if I say something like 12 divided by 0, how many times you have to add 0 to itself to get 12? Is it 12? No. Is it 0? No. It is undefined. If you were to say that, 12 divided by 0 is equal to 0, then you're implying that 0 times 0 equals 12. If you were trying to say that 12 divided by 0 is equal to 12, you'd be trying to say, okay, 0 times, are you trying to tell me that 0 times 12 equals 12? None of these things are true. The answer when you divide by 0 is undefined. It is illegal to divide by 0. This is a very important rule. Something else you should know is there are a couple different ways of writing division. So let's talk about some of our syntax here, or our terminology. If I've got something like, say, 12 divided by 6, and I say this is equal to 2. The names of things here, what I'm dividing by is called our divisor. Our answer is called the quotient. Later, we're going to end up with remainders. The number that we're dividing is actually the dividend. This might be helpful for us later. Other ways of writing this. So this is with kind of that arithmetic notation. We've got the line with the dot above and below. We also have basically a fraction notation. All fractions are division problems. It's always the top number divided by the bottom number. We also have this long division. So this is more as a fraction. This is also with a long division bracket. And the divisor goes outside, the dividend goes under the long division bracket. And of course, the quotient goes above. 2 times 6 would be 12. And we'd usually write that below. Okay, so here's some notes about syntax and some of our terminology. Let's go over the process for long division. And what you're going to do, the process for long division always breaks up into 3 steps that you're going to repeat. Estimate, multiply, and subtract. And a couple notes with this. Then you're going to repeat. A couple notes with this is you are likely, each of these things can present some difficulties. So I'm going to show you some places that you can check your work in the middle. Let's say we've got something like 5,841. And I'm going to divide this by 9. What I'm going to do is I'm going to look at my leftmost digits. I can tell that I can't put 9 into 5 because 9 is larger than 5. But there is a multiple of 9 smaller than 58. So what you're going to look for is we're going to look for multiples of 9 smaller than 58. It might be helpful to basically make a list of our multiples. This is something that can help you. So if I think about like 9 times 1, 9, 9 times 2, 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72, 9 times 9 is 81. You're only going to need to go up to 9 because I can't put 2 digits in one place value. The other thing that you're going to do, so I'm looking for just some multiple of 9 that is just less than 58. So I'm going to look at that and I see 54. What we're going to want to do is we're going to want to line up the place value. So 6 goes here, 6, so we're estimating. 6 times 9 is 54. That's the multiplying. And now we subtract. 58 minus 54 is going to be a 4. Now, I'm going to bring my next digit over. This 4 is going to come down, and I'm going to start to repeat this process. How many times would 9 go into 44? Well, if I estimated too low, I'm going to, and by the way, if you estimate too low, if I had put a 45 down here, this difference, that original difference, would have been larger than 9. So your difference should be smaller than your divisor. Okay, let's go back to this one. It looks like my next one is going to be 4. 4 times 9 is 36. When I subtract, okay, this is going to be 8. So these differences, that 4 right there, this 8 right here, that is smaller than 9. If this is 9 or more, my estimate was too low. Now let's bring my last digit down. And I've got a 1. 9 goes into 81. Looks like 9 times. 9 times 9 is 81. And I've got 0 left over. And I've got no more digits. So my answer here is 649. So this is your general process. Estimate, multiply, and subtract. Let's do this again. Only this time I'm going to have one other thing that's going to happen with this. This is going to be a long division with a remainder. So let's do this. I'm going to do 608, only this time I'm going to divide this by 5. No, 5 would go into 6 one time. 1 times 5 is 5. 6 minus 5, that's 1. Let's bring this 0 down. 5 will go into 10. Oh, that looks like that goes in there 2 times. 2 times 5 is 10. So I've got a remainder of 0. That's nice. Let's bring down this last number, 8. 5 will go into 8 one time. 1 times 5 is 5. I've got 3. But now I don't have any more digits to bring down. This is what we call a remainder. So I've got my quotient and my remainder. I could write this as 121, and sometimes we'll write this as an R of 3. Now, as we go on, we could do different things with these remainders. We could, in fact, make these into fractions, but we're not doing that yet. Or not necessarily we're going to do that yet. So this could turn into 121, and this would become the numerator of a fraction, so 3/5. The denominator always stays the same. That would be my divisor. So as a fraction, that could happen here. As a decimal, I would just, that's 608, 5, 121, 5, 10, 5. As a decimal, what we would do is we would put a decimal point after our whole number and start tacking on a trailing 0. And then the decimal point goes above here. 5 would go into 30, 6 times 5 is 30, and I've got a remainder of 0. So depending on what we're doing, we're going to do different things with the remainders. Sometimes we're just more interested in knowing what number is left over. And there's some topics later on in algebra that you can run into where you're looking for remainders. Okay, that's what I've got for you guys right now, and I will see you in the next video.